All right, so here's another one. Again, pause the video, see if you are able to come up with the same thing. Keep in mind it might be okay for us to come out with a little bit slightly different process. Okay, so hopefully you took the advantage of trying to pause the video and seeing if you were able to solve this proof. All right, so our first statement should once again be our given, which is 3, 2x plus 2 equal to 30. And again, that was given. All right, our next step, or at least the next step I'm going to take, is I'm going to take that 3 and I'm going to distribute it out amongst our process. You could have, if you wanted to, you could have also divided. So there is, again, a couple of different options. It just depends on the way that you want to see solving this problem. So I can actually work this one two different ways. So this first time, I'm going to go ahead and do the distributive property. So that would be 3 times 2x, which is 6x, plus 3 times 2, which is 6, equal to 30. And again, that was by distribution. Now I would subtract both sides by 6. And if you want to write it, you can write it out. You don't have to, though. So 6x is then going to equal 24. And that again was by subtraction. And then now we would divide both sides by 6. And that would leave us with x equal to 4. And that was again by division. All right, so that wasn't too bad. But like I said, there is another step. We could have done things a little bit differently. So I'm going to show you that real quick, and I'm going to erase this up to the point of the given. And just show that, again, if you had seen this problem slightly different, maybe approached it a little bit differently, that's okay. Sometimes that's what we do. All right, so the thought I had here is that, well, what if I decided to divide both sides by 3 rather than distribute? That's a legal move. We can do that. So that would have left us with 2x plus 2 equal to 10. And that was again by division. And then from there we would subtract by 2. And that would leave us with 2x equal to 8. And that was again by subtraction. And then now again by division. Divide both sides by 2 and we get x is equal to 4. So as you can see, you can approach it by two different ways, especially since these are algebraic problems. Neither one is right or wrong. Again, just make sure that you are following the legal rules of multiplication, division, adding, subtracting, and our order of operations. Don't try to do anything out of order or out of sequence. It still has to be a proper legal algebraic move. All right, so there was 2 ways on that one. All right, so as they get a little bit longer, you can kind of see again, we're going to have the same type of scenario. We could have probably most likely approached this in multiple different ways. Notice this time, though, they are giving us more than one given value. So for starters, we want to go ahead and list that. So we have given a, open parentheses, b plus 2, close parentheses, equal to 45, and that a is equal to 3. We want to prove that b is equal to 13. So let's go ahead and write out our first statement. And that's, of course, because it's given to us. So again, a inclusive b plus 2 equal to 45. And we're also told that a is equal to 3. And again, you can list that all on one statement, or you can split it up as I've just split it up. It really is a personal preference thing. And sometimes when I have a lot of information, I will do that, put all of it in one statement, but it's really not that big a deal. All right, So since we are being given that A is equal to 3, and we have our A in our first given statement, let's plug in 3 for A. So that would be 3, and then B plus 2 equal to 45. All right, so we did that by substitution. We plugged in the value of 3. Okay, so it was substitution allowed us to plug in that value of 3 into A because A is equal to 3. So now, once again, we're going to go ahead and we'll do the distributive property. So 4, we're going to distribute 3. So that's 3 times B plus 3 times 2, which is 6, equal to 45. And that's the distributive property. All right, and then now let's go ahead and subtract 3 from both, or 6 from both sides. So this is going to be step 5. So 3b equals 39, and that was by subtraction. And our last final step for this particular problem, we would need to divide by 3. So b equals 13, and that was by division. All right, again, there you go. We probably could have approached things a little bit differently as well. We could have done it similar to our last problem, but hey, let's just keep moving on. All right, so now let's take a few properties and start blending it in with some geometry. All right, so here we are. We are given that the angle RST is equal to 50. We are also given that the angle TSV is equal to 40. By the image, we can see that ST is also our adjacent side. And also, if you notice, even if we had not been given the image, you can see that we have ST in both of our images, or in our statements. So therefore, we could assume also at that point that we have a common side between those two. Then they give us that the angle X over here is also a right angle. We need to remember, what is the definition of a right angle? A right angle is an angle that has the exact measurement of 90 degrees. And think about how when measurements are all the same, that we would end up with congruent angles. So we're going to probably want to use a couple of those different types of properties. All right, so let's go ahead and list out. Let's go ahead and just start with our angle RST and angle TSV. All right, so I think I'm going to go ahead and list both of those in the same statement. All right, so angle RST equals 50. And of course I said that, and then I can't fit it, so let me erase just a little bit so that I can fit it all together. How about that? All right, so angle RST equals 50. And we have angle TSV equals 40. I think I'm going to bring up the angle X here in a little bit. All right, so that's given. So there's an example of how you can just, combine some of the statements into one, which will mean we probably won't use all of the table that's provided for us. All right, so let's think about it. How can we bring the angles together to equal 90? So let's just think about that for a second. So we've already talked about how ST is probably an adjacent side. It's also given the image. So probably we could look at angle RSV. Let's try that. So we could say angle RSV would actually be equal to the angle RST plus B. Okay, so that's statement, and that's actually angle addition. When we have an adjacent angle, because we've already determined, we can see that we have that. All right, so let's go ahead and plug in what we know. So angle RSV, RST is equal to 50 degrees, and TSV is equal to 40 degrees, and that would be by substitution. All right, so you can see we plugged in the values that we know. All right, so let's move to a different. Now let's go ahead and say, okay, well, 50 plus 40 tells us that RSV must be equal to 90 degrees, and that was by addition. Okay, so far so good. All right, and so that also tells us, you see in this case, we might actually be running out of room, which is just fine. We can always add some more columns. All right, so 5, then that tells us that RSV is a right angle, and that's by the definition, of course, if, we have, let's see if I can put this all in, if an angle is a 90-degree angle, then it is a right angle. All right, almost ran out of room. All right, and again, like I said, we're going to probably need to add another statement here, which is fine. Let's see. Let me go ahead and split this box. There we go. All right. So, changing some colors. We also need to go back to the fact that we know that angle X is also 90 degrees. And that is a right angle. And of course, we know that because it was given. So now, to get to our proof statement, we can say that our last and final step is that angle RSV is congruent to the angle X because, well, if you have two right angles, or if two angles are right, let me make that a little bit smaller. Right angles, and again, I'm going to abbreviate just a little bit so that I can fit it all in here. Then they are congruent. And again, you can abbreviate. Actually, my suggestion would be to start abbreviating. Now, we probably could have approached this a little bit differently and maybe not added in some of the extra steps in there. But again, just keep in mind, we've got to prove every step that we take, and we must justify each of those steps as we go through them. All right, let's take a look at another geometric proof. All right, so we have L is parallel to M. And it appears we have it also being cut by the transversal N. We have all these angles, and they want us to prove that angle 2 and angle 7 are congruent. Now, we have learned some of the properties, but again, this time what we want to do is we want to justify it, and we can identify it afterwards so that we have a special property that we are going to prove. So if you recognize the position of these two angles, kind of think about it in the sense of we are proving that that theorem is true. All right, so let's go ahead and state our statement. So our statement number 1 is L is parallel 2m. And again, that is given. All right, sounds good so far. All right, so let's first kind of look and see what kind of relationships we can bring about. So we should recognize also that 2 and 6 are corresponding. So we could probably use that. So angle 2 is congruent to angle 6. And that property and definition, if you remember from our previous unit, is that if parallel lines are cut by a transversal, then the corresponding angles are congruent. And again, abbreviating. I'm going to keep working on abbreviating these concepts. We don't want to have to waste a whole lot of paper just because we have to write out a definition. All right, so if that's the case, then we need to look at our relationship of angle 6 to angle 7. And hopefully you recognize that those are vertical angles. So 3, angle 6 is going to be congruent to angle 7. And again, that's by the definition of a vertical angle. And that just states that vertical angles are congruent. Okay. Now, if angle 2 is congruent to angle 6 and angle 6 is congruent to angle 7, what must be true about angles 2 and angle 7? This is another example of the transitive property. So again, angle 2 is congruent to angle 6. Angle 6 is congruent to angle 7. Therefore, angle 2 must also be congruent to angle 7. That does give us our proof statement, and that was the transitive property of congruence. There you go. And see, we didn't even use all of it. So we've had examples of using all of our statements plus or blanks plus them, and here we have where we didn't finish. We finished it off beforehand. All right, I hope you have found the introduction to proofs not as terrifying as many want to make it out to be. We will continue to work through these. Again, make sure you have good notes and that you have good vocabulary listings and all your properties as well, because they will come in handy. See you again soon.